Welcome to AI Safety and Guardrails. In this lesson, we'll explore 10 essential concepts that help build AI systems which are accurate, secure, fair, trustworthy, and Have you ever seen an AI answer confidently but still be completely wrong? That's called an LLM hallucination, one of the biggest challenges in generative AI. Hallucinations happen because language models predict the next most likely words based on learned patterns instead of verifying facts from trusted sources. For example, when asked who won the 2022 FIFA World Cup, a hallucinating model might answer Brazil, even though the correct answer is Argentina. Hallucinations can be reduced using retrieval augmented generation, better prompts, higher quality training data, and human verification for important decisions. Always remember, AI confidence does not guarantee correctness. For critical domains like healthcare, finance, and law, every important answer should be verified before use. An AI can be highly intelligent but still produce harmful outcomes if its goals don't align with human values. AI alignment ensures models behave the way humans intend. Alignment becomes critical wherever AI makes real decisions, including healthcare, finance, recruitment, cybersecurity, where incorrect decisions can seriously impact people. Building aligned AI starts with defining correct goals, training with quality human feedback, applying safety monitoring performance, and improving through user feedback. Building aligned AI starts with defining correct goals, training with quality human feedback, applying safety monitoring performance, and improving through user feedback. Without alignment, even powerful AI can confidently make harmful decisions. Trustworthy AI begins with goals that are aligned with human values, fairness, and safety. Guardrails act like security checkpoints for AI. Input guardrails inspect user requests before process guardrails verify responses before they are shown to users. Input guardrails block harmful prompts such as requests for confidential customer data, preventing unsafe or unauthorized instructions from reaching the language model. Even if the AI generates sensitive information, output guardrails detect personal data, policy violations, hallucinations, or unsafe content before the response is delivered. Together, input and output guardrails protect production AI systems and unreliable responses, making AI significantly safer for real-world applications. Prompt injection is an attack where malicious instructions are hidden inside user input or retrieved documents, attempting to override the AI's original system instructions. There are two common types: direct injections type malicious prompts, and indirect injection are retrieved by the AI. Attackers also use jailbreaks to bypass safety rules or manipulate AI agents into performing unintended actions, like revealing secrets. The best defense is layered security, strong system prompts, input validation, trusted retrieval sources, and guardrails that ignore malicious instructions hidden inside retrieved content. AI bias occurs when models dramatically different outcomes for certain groups, usually because they learn patterns from imperfect or unbalanced training data. Bias can originate from many sources, including biased datasets, historical decisions, subject-linked, underrepresented populations, model design. A common example is a hiring model that favors one group because it learned from historical recruitment data, creating unfair decisions without explicit human instructions. Reducing bias requires balanced datasets, fairness metrics, regular audits, diverse testing, human oversight, and continuous monitoring, because bias can appear even after deployment. Responsible AI means building systems that are fair, transparent, private, secure, and safe, not just accurate. Building responsible AI starts with governance policies, risk assessment, quality data, bias testing, and continuous monitoring after deployment. A common example is a hiring model that favors one group because it learned from historical recruitment data, creating unfair decisions without explicit human instructions. Responsible AI builds long-term trust by combining ethics, governance, fairness, privacy, security, transparency, and continuous improvement throughout the AI lifecycle. Explainer answers an important question: why did the AI make this decision? Instead of only showing the result, it reveals the reasons behind it. A simple rejection gives users no insight. Explainability provides meaningful reasons, making AI decisions easier to understand, review, and trust. Explainability tools identify which features influence the prediction, helping developers detect errors, improve models, satisfy regulations, and build user confidence. Explainability improves transparency, supports regulatory compliance, helps identify model errors, and ultimately builds trust between AI systems and the people who rely on them. Interpretability and explainability sound similar, but they're different. Interpretability helps us understand how a model works, while explain helps us understand why it made a specific prediction. Interpretable models, like decision trees, reveal their logic directly. You can clearly follow each decision rule from input to final prediction. Complex models like deep neural networks cannot easily explain themselves, so explainability techniques identify which features contributed most to each prediction. Simply remember, interpretability explains the model itself, while explainability explains an individual prediction made by complex AI models. Trust in AI isn't created by marketing. It's earned through accurate predictions, transparency, fairness, privacy, and reliable human oversight. A trustworthy imitations protects sensitive data, provides accurate results, high-risk situations to qualified human experts. User trust grows when AI delivers reliable results, explains important decisions, safeguards personal information, and treats every user fairly. Trust is built through every interaction. One incorrect, biased, or insecure response can quickly damage user confidence in an AI system. Grounding improves AI reliability. We connect language models with trusted documents, databases, or APIs. This happens before generating an answer. Instead of relying only on training data, grounded AI retrieves relevant information, provides it as context, and generates answers supported by real evidence. Without grounding, an AI may guess company policies. With retrieval-augmented generation, it retrieves the latest HR documents and produces accurate, evidence-based responses. Safe AI combines hallucination reduction, alignment, guardrails, prompt injection defense, bias mitigation, AI systems for the real world. Thank you for watching. I hope this lesson helped you understand the foundations of AI safety and guardrails, generative AI, lag, and AI engineering. Happy learning!